Okay. All right. So number 1 here. Now you may want to just go ahead and put a star beside it right now, because I can promise you that it's going to be on the summative. Now it may not be like this. It may not be in this. I'm not saying that the answer is going to be this. I may. Well, let's just do it, and then I'll kind of explain to you what I might do on the summative. Wink, wink, hint, hint, kind of thing. Okay. So a unit rate. Now we all know that a unit rate is what?
How much
Good talk.
per one? How much of something is per one?
Yeah, it's how much of one thing per one of another. So I'm just going to write per one. You always need to be writing what I'm writing. Okay? The amount of one thing per one of another. So how many girls per boy? I just said write something. How many boys per girl? How many basketballs per player? How many students per teacher? It's all about the second label. It's one. We're doing per one. So let's think about this. What can a unit rate be used for? This was the most missed question on the test. I think like 4 or 5 if you got it right, out of 30. And I kind of expected that because it's a tricky question. It is. But hopefully after we go over it, it won't be so hard. So let's go through here. Can you use a unit rate to find missing measures in an equivalent ratio problems? What do you guys think? Okay. Here, I'm going to do this. I'd like you guys all to write this too. For A, let's think about this for a second. Let's say that I had 5 boys for every 6. No. What's the matter? Sorry. Hey, how bad would you be if I told you to erase it? Sorry. All right, 10 boys to 5 girls. I'm positive this time. Okay, and then I said, okay, I want to know how many boys I would have if I had 8 girls. Okay, now, obviously you all know that. Could you cross multiply and divide here? Yeah. Absolutely. But let me make sure you understand that this is exactly what A is saying. It's saying to find missing measures in an equivalent ratio problem. Okay, so here we have an equivalent ratio problem. Do you guys agree with that? Let's see if we can use unit rate to solve. So, I'm going to write this again. 10 boys. But what should I do here? Now, I'm going to find the unit rate. How many boys would that be per girl? 2 boys. Now, this is where I would have done this little thing. This is no different than use unit rate to solve. And then I would take the unit rate, 2 boys per girl, and I'd say, okay, well, what if I had 8 girls? Times 8, times 8, 16. Guys, did I just use unit rate to find missing measures in an equivalent ratio? Yes, I did. Okay, that's exactly what I'm talking about. So let's write next to letter A. Let's write it up here. Let's say, we'll kind of put it in quotes maybe. Use unit rate to solve. That's learning target number 7. That's exactly what 7 says. Okay? Whenever it says use unit rate to solve, that's what you're doing. You're figuring out the unit rate in order to find some unknown information. And that's what letter A is saying. So right now, did we prove that A is true? So right now, we know the answer is either A, D, F, or G, right? Because we know A for sure, we proved it. Now, B, to determine when a pair of rates are equivalent. Okay, well, let's think about that for a minute. Okay, let's look at B. Okay, I have 2 rates. I have, let's say, 12 students to 4 teachers. And I have the ratio 18 students to 6 teachers. Now, you guys know there were 3 methods. Listen. There are 3 methods that you learned to be able to check for equivalency, right? You could use cross products, right? You could simplify them. Or you could divide them, correct? Yep. Guys, when I do 12 divided by 4, what you're doing is you are finding a unit rate. Watch. You are saying, oh, so you're saying that if I do this, wouldn't I just be doing 12 divided by 4? Hello?
Yes.
So isn't that 3 students per teacher? Guys, when you do 12 divided by 4, you get 3. What's the ratio then? Isn't it 3 to 1? So isn't every whole number, if you thought of it as a rate, if you're comparing it to something else, isn't it going to be a 3 to 1 ratio? So this one over here, I'm going to find the unit rate. 1 teacher, divide 6, divide 6. That's going to be 3 students per teacher there. Did we just prove that we can definitely use unit rate to check for equivalency? Okay. So now we know that there's multiple answers. So we know, now we're kind of getting it simplified that it can't be A, it can't be B, right? Because we know it's A and B. Does that make sense? It can't be A and B. So now we know that, really, we know it can't be C also, right? It must be either D or G. We were kind of just going through the process. Now, letter C was the one that most of you selected, which is absolutely true. Absolutely. We're going to do a better by question later on. Isn't that exactly how I taught you to do better by? Unit rate. So we just proved that this has, all 3 of these are true, and the only one would be letter G. Okay? Now, for the summative, I'm just going to go ahead and prepare your mind right now. I'm not saying that on the test it's going to be all of them. I may throw something weird in on letter C and let you get like something different, and then you'll have to pick. It might not be the same thing. So I don't want you to think it's automatically all of the above or A, B, and D or whatever. I want you guys to actually think about those things. But it makes perfect sense. Unit rates absolutely can find missing measures in equivalent ratios. It absolutely can determine if ratios are equivalent. And obviously it can help us with better by. We all cool on that? All right. So there was no learning target for that, but you didn't need any work. It was just right or wrong. Okay? Okay, number 2. Now number 2, don't worry that it's got a big X through it. I didn't mean to do that. So we'll just kind of read it. There are 12 girls and 5 boys in academic lab. Shouldn't I have identified that as my fake ratio or my fratio? That's exactly what that is. So what I like to do is I like to go up and do my edge pieces. Now, you didn't have to do this. People keep asking me throughout the test, do I have to do edge pieces? Hey, you do whatever you want. But I'm just telling you that it helps. And I wouldn't tell you to do it if it didn't help. It just gets your thoughts organized. I know that my edge pieces are 12 girls, 5 boys, which means 17 total. So now I can have all these different ratios right here. I know the ratio of girls to boys is 12 to 5. I know that the ratio of boys to girls is 5 to 12. And then I can figure out the part to whole ratio as well, 12 girls to 17 total or whatever. Okay, now what I'm going to do is I'm going to add 5 boys and 5 girls. Is the ratio of girls to boys still the same? So I know that the original ratio was 12 girls to 5 boys, right? Right? After I add those students to the class, now I'm going to be looking at 17 girls and 10 boys. So let me write this up top here. So boys, and you guys should be writing this, by the way. You absolutely, why wouldn't you? Because this is now your study guide, so it's going to be 17 girls and 10 boys. Well, here we have 2 ratios, correct? How many different methods do you know how to check for equivalency? Yes? Wait a minute, how many different methods do we know how to check for equivalency, though?
There's 3, but there also might be.
There could be a 4th, and the 4th one actually works here. Guys, when I look here, I'm looking at it going, wait a minute, wouldn't that be times 2? Hello?
Yeah.
But is 12 times 2 17?
No.
So right away, I know this is no. But then you could do cross products. 10 times 12 is 120. 5 times 17, 34, 68, 85? Obviously not the same. You could simplify them. They already are in simplest form. Okay, you could divide them. Not going to do it, but you could do any of those methods. So right away, we've eliminated letter A because they're clearly not going to be the same. Okay? Now we got to figure out which reasoning is right. So letter B. No, because the unit rates do not match. The ratios will not be equivalent. Okay? Now we just learned in number 1, can you use unit rates to check for equivalency? Absolutely you can. So right away, this one could be right. But let's go to C now. No, because you would have to add 6 girls and 3 boys in order for the ratios to be the same. So what you had to do now to check C is you actually had to do this again. So again, write this. So here we have our original ratio, 12 girls. Write this to 5 boys. Okay, now I'm going to add 6 girls, so that's going to be 18 girls to 8 boys, right? Now here we're in the same process. Guys, just understand something. I know when you guys see the word add, you automatically think, oh, well, you can't add to make equivalent ratios, which is true. But if I gave you something like this, like if I gave you 10 to 5 like that, and then I said, okay, let's say you added, let's say this was 10 boys to 5 girls. And I said you added 4 boys. You added 4 boys. So now you have 14 boys. And down here, you're going to add 2 girls. Would those be equivalent? Huh?
Yeah.
Absolutely it would be. So don't just think because you add. The whole deal with adding and subtracting, you can't just go have a fraction or a ratio 1 to 2 and say I'm going to add 1 to top and bottom and get something that's equivalent. That can never happen, right? But you can add different amounts and get something equivalent. So you got to check it. You guys see what I'm saying there? So on this one, again, we got to do all those rules that we've tried. Okay? We can simplify them. This one's already in simplest form. This one would simplify to 9 over 2. So are they the same? No, they're not. So these would not be equivalent. By the way, that little, I don't know if you've ever seen that before. An equal sign with a line through it means not equal. Not equal. Okay? You could do cross products. That would be fine too. It would prove that they are not equivalent. Does that make sense though, guys? So I have a feeling that nobody in here did this work. And I think maybe a lot of people got it right. I'm pretty certain. But just understand that you can add different amounts to get something equivalent at times. So you always got to carry it out. The answer is letter B. Okay? If there's nothing written, there isn't a learning target because I didn't really know where to fit it in to the learning targets. It's just kind of in there, you know what I mean? All right, number 3. Okay, I don't think I need to do too much with this one. This is just a basic point booster for you guys. It's learning target 5. Obviously, you just go ahead and cross multiply and then divide. You're going to get, I believe, 12, right? Okay. So give yourself a check or an X on learning target number 5. Okay, this one here. Now, for those of you that watch the video, by the way, this is learning target number 1 here. Okay. So learning target number 1, you will give yourself either 6 checks or 6 X's. This is worth 6 points because there's 6 different spots here. So 1, 2, 3, 1, 2, 3. Okay. Now, for those of you that watched the video, I pretty much told you that the question was going to be there, right? I told you it's going to be there. It's going to be on the summative. I can promise you guys that on the summative, you're going to see this exact same question, only instead of it being 3 containers of strawberries, it's going to be 5 or something like that. I don't know that for a fact, but you know what I mean. It's just going to be different numbers. So if you understand it, it's basic math. The math itself is very basic. So, William. Okay. Here we have the fake ratio. Now, you could go up and do edge pieces if you wanted to and say, okay, I know that my famous fruit salad recipe serves 30 people. I know that it calls for 3 strawberries. I know that it calls for 6 grapes, bags of grapes, of course, and 12 oranges. Okay? And when I look at that, that's all fake information. Now, I could add it together, and I could say that means that I would have 3, 6, or 3, 9, 21 total items of fruit, I guess, if you want to think about it that way. You don't have to. It's all organized in the table for you. Okay? The fake information was all organized for you. Okay? So, now, I only have 10 people coming to my house. That's all I have. So, there's no sense in me making my recipe that serves 30 people if I've only got 10 people there. Does that make sense? So, all you got to do is say, well, if I can figure out what I'm doing to my number of people, then I can just do that same exact thing to my number of items of fruit. So what am I doing to my people? Dividing by 3. So what do I got to do to my bags of, or my containers of strawberries? Divide by 3. So that means I'm going to have 1 container of strawberries. That's all I need to buy at the store. Okay, here I have my grapes. I'm going to take those. I'm going to divide those by 3. Now I know all I have to buy is 2 bags of seedless grapes. My oranges, I know I've got to divide those by 3. That means I need to just go and make sure I have at least 4 oranges in the fridge. Very basic, right, guys? Whatever you're doing to your people, you do to your ingredients. Now I'm having more people at my house. I'm going to bring 50 people into my house. So now what am I doing to my number of people?
Times 5.
Times 5. Okay? So what am I going to do to each ingredient? Multiply it by 5. So 5, 2 times 5 is 10. 4 times 5 is 20. Okay? So obviously that's worth 6 points right there. 6 total points. Everybody understand that? So that page is out of 9. Okay? Let's go to the next page. All right. Now, these first two right here, they don't really have a learning target because they kind of just come with what you got to do. They kind of go with 6 in them, but we won't do checks or X's. What's the first thing you should have done right here? You should have done your edge pieces. If you didn't, please do them now. And some of you might say, I don't need to. Well, that's fine. But just trust me when I say it'll help you to organize your thoughts. Just trust me on that, please. In the computer lab, there are tables and chairs. Okay, the ratio of tables to total furniture is 4 to 13. So I know that tables comes first, so that means the 4 must represent the tables. Now on the video from the other night, I made sure to tell you don't just put T because you're going to have total in there too. Now 13 is representing the total furniture, so there we go. It's going to be 13 total. Okay. Now most of you are pretty good at this. You're able to just kind of say, okay, well then that means if there's 13 total, 4 of them are tables. That means 9 of them must be chairs. If you're somebody that struggles with that idea, just say, okay, here's my 13 pieces of furniture. 8, 9, 10, 11, 12, 13. I know that 1, 2, 3, 4 of them are tables. That means the rest must be chairs. So just add them up if you need to do that. I don't think we do, but just wanted to throw it out there. Okay, so now it's all about reading. These are reading questions, 100%. More reading than math, to be honest. Okay, what is the ratio of tables to chairs? Well, if tables comes first, you go up here and say, okay, it's going to be 4 to 9. Also could be written as a fraction in fraction form, or you could write it with the word 2 in between. Either way, 4 to 9. Okay, what is the ratio of chairs to total? Go up to your edge pieces. Very simply, 9 to 13. 9 over 13. Or 9 to, or 9, you could write out of 13 too also.
Did we have to do all of those?
No.
Just one.
I'm just giving you I'm just giving you the options. You could have just one of those. I assume that most of you probably did this one because that's what you typed in your clicker. What? Okay. Here we go. Number 12, this learning target number 6. First thing you should do is always start with your proportion. Okay, always start with this proportion right here. What should go on your proportion before anything else?
Labels.
Labels. You got to figure out what labels to use. Up here we have 3 different labels. We're obviously only going to use 2 of them. So this is where you've got to read into your real information. Remember, up here, this is fake stuff. All this is fake, 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 fake. I've been showing it in yellow since the beginning of chapter 4. Now we'll go to this one. There's your real information. The real information will be like, if this, then how many of this? So I always go through and just start underlining. Okay, well, if there are 27 chairs, so there's one piece of information, real information. How many total pieces? So where does total always have to go on a proportion? Bottom. So there's my total. And it may not be a bad idea to do TOT or something like that. Okay? And then it gave me chairs, so I must be comparing chairs to total. Because that's what it gave me. If it would have said tables here, we would be doing tables to total. But since it says chairs, you got to use chairs. So remember this here. This first ratio is always what's called your fake ratio. You always get that information from your edge pieces. And I know the ratio of chairs to total is 9 to 13. My real information is that I have 27 chairs. From this point, you could do this 2 ways. You can just know that you'd be multiplying by 3. Are you going to pick it up? Just be multiplying by 3. Or you could cross multiply and divide. Either way, you're going to figure out that that would be 39 total pieces of furniture. You must have that work with labels. If you don't have labels, count it wrong. I will take off points if you don't have labels on the summative. Okay, now this one, here we go. Again, guys, if you just do it my way and put the labels on before you start putting numbers, you will benefit, trust me. Here we go. Here's my next real question. Okay, if there are 24 tables now, so I know one of my labels is going to be tables. So tables in the room. How many chairs are they? So we know we're going to do tables to chairs. Could I also do chairs to tables? Absolutely I could. Does it matter whether I said chairs to tables or tables to chair? No. Boys to girls, girls to boys. All part-to-part ratios can be flipped however you need them to. So we're going to go back up to our edge pieces to get this. What is the ratio of tables to chairs? 4 to 9, right? And then what piece of real information did they give me? 24, right? What am I doing to my number of tables? Times 6. So I've got to multiply my number of chairs by 6. It's going to be 54. Could I have also cross multiplied and divided there? So I could have actually just went 24 times 9 divided by 4. Either way. Okay? All right, next one. Okay. We have J-Dog fouls out 9 out of every 15 games. So again, not a bad idea to do your edge pieces here. Okay, just to kind of organize your thoughts. He fouls out 9 games, so 9 foul outs. Okay, out of every 15 games. So that means he's playing in 15 total games, right, guys? So in how many games did he not foul out?
6.
6. I'll do NFO, not foul out, or whatever. Doesn't really matter just as long as you understand what you're talking about. Okay? So, how many games would he foul out? There's one label. If he played in 55 games. So you know, you're comparing foul outs to games played, or total games, however you want to say it. Okay? Get this information from right here. I know it's going to be 9 foul outs for 15 games. And my real information, I just plug it in. It's going to go right there. 55's there. Right? Anybody in here know what you're multiplying by to go from 15 to 55? Me neither. So that's why this is the time where you'd want to go, okay, I'm going to do 9 times 55 divided by 15. What's the answer? 33 times he would foul out. Those are equivalent. Good? Yeah, he's a... Is it on your paper, guys?
No.
It's number 5, yeah. Sorry. Okay. Up here, another one of these, just like one we previously just did. If I were doing edge pieces, which I would encourage you to do with me as I'm doing them here, Gwen Keener makes 3 out of every 12 total free throws, so she's got 3 makes. She's got out of 12 total. So how many misses would she have? 9 misses. That's just basic subtraction. Again, when you know the whole, then you're going to be subtracting to find the other part. Okay? So we start with our proportion. We got to go to the question. The question's always going to contain the real information. So I look right here. Okay, it's not going to do what I want it to. Okay, there's my information right there. So, how many free throws did she shoot? Wouldn't that be total, guys?
Nope.
That would be a total because she's shooting that many. So I'll just put total on the bottom, of course, if she made 18. So we know we're talking about makes. And makes. So my fake ratio of makes to total is 3 to 12. Well, what if she made 18? What am I doing to my number of makes?
6.
Times 6. So what do I got to do here? And that's going to be?
72.
72. And then obviously you could have cross multiplied and divided as well. Same thing. Okay? All right. Number 16 and 17. These are both learning target number 7. These are the only 2 learning target 7s on this test. Okay? You have to do what it says right there. You have to do it. If you didn't do it, it's wrong. So I told you guys, whenever you see this, it's not a bad idea just to split your space in half. Okay? Because you know, whenever unit rate's involved, you have to do a proportion to find unit rate. That's number 1, right? Always. That's chapter 4 stuff. But now we're taking that unit rate and we're applying it. So here's my proportion here. I know that my fake ratio says that that a snowstorm dumped 18 inches of snow in 12 hours. Okay, how many inches will it snow in 20 hours? Now, because it gave me 20 hours, the idea is if I can figure out how many inches per hour, then I can just multiply it by 20, right, William? Okay, so we have inches to hours, inches to hours. So this is going to be my fake ratio, inches in 12 hours, right? So I need to figure out how many inches were dumped in 1 hour. Okay, so I'm dividing by 12 to go from there to there. What do I get? 1.5 inches in 1 per hour. Now I need to take that and I need to then apply my unit rate now. So I'm not going to change anything. I'm still going to use my unit rate, only now my unit rate is going to be the fake ratio. You guys all understand that? So now this is going to be 20 hours times 20 times 20 is going to be 30 inches. So the way I've been teaching it, everybody pay attention. This is my fake ratio. Remember, unit rate, we've always I've tried to make pink as much as I can, like when we do the models and stuff. Okay? And then finally we got to our real information. You guys see how I did that?
Yeah.
So we got a proportion finding unit rate and a proportion using unit rate to find the unknown. Do you guys see how I did that? You had to do that. If you didn't have that, it's wrong. Okay. A race car can travel at a speed of 186 miles in 3 hours. Okay. How far can it travel in 5 hours? Again, if we can figure out how many miles that car traveled in 1 hour, then we can just, it's very simple. That's the whole point of using unit rate. So again, we must split this. So now we're talking about miles in hours. Miles, hours. It's 186 miles in 3 hours. I need to figure out how far it's going to travel in 1 hour. Divide 3. Divide 3, what's it going to be?
62.
Get your head up. 62. Now I'm going to take that unit rate and I'm going to apply it to how many hours I want to know. So again, it's miles, hours. Miles, hours. Okay? And I will take points off if you don't do labels on the summative. So if you're not doing them now, you know, I would be definitely writing yourself a note because it will be a half off. It's on the video, so there's no excuses. If you don't use labels, it's going to be wrong. Sorry. Okay, I know that I'm going to use my unit rate here, and then I just answer the question, the real information. It gave me hours, so times 5. Times 5, what's it end up being?
310.
310 is my real answer, my real information. Good? Okay, next one. Okay, now these are going to be 4 separate questions as well. Okay, now remember, whenever you're doing unit price, that is the cost per one of the object. So what label always goes on top? Money. So you had to have 4 proportions here. Okay, so we know that money, and then whatever the fruit is, we'll put that in later. Money always goes on top because we want to find the cost per one of the object. Here we got oranges here. What's the next fruit? Kiwi? What's the next one?
Pear.
And then pear. We'll just do P. Okay. My fake ratio for the oranges was $3.50 for 7 oranges. I want to figure out how much 1 orange costs. When I do that, divide 7, divide 7. Could I also do $3.50 times 1 divided by 7? Yes, I could. I'm going to get not 0.5, but
0.50.
it's got to be that. If you had 0.5, it's wrong. That is not money. Money is always to 2 decimal places. If you had 0.50, that's fine. Same difference. Okay, number 19 is going to be 5 kiwis for $1.95. So $1.95 there for 5 kiwis. What do I get as my unit price this time? 39 cents. So I have 0.39. Good. Okay. My plums, 9 plums for $2.43. I need to figure out the cost of 1 plum. Divide 9, divide 9. What's that going to give me? What is it? 27 cents. So there we go. You know these are all Learning Target 8, by the way, right? Okay, and finally the last one, we know it's 93 cents for, is it 3? Is it 3 pairs? 1 pair, that's going to be 31 cents, right? Okay. There we go. So, unit price. Do you think that same exact question is going to be on the summative, guys? And that's what kind of frustrates me a little bit, because You know it's going to be on the summative. There's no mystery to what's going to be on there. It's going to be there. Okay, don't even worry about it. Okay? All right, now we've got to figure out what would the total price be if you bought 4 of this and 2 of this. Now, obviously a lot of you, I was getting a lot of weird answers. A lot of them. I had a lot of people getting like these weird decimals, and I don't understand what you guys are making it so much harder than it has to be. Just do 2 separate proportions. It makes it so easy. Watch. So I know that my unit price for the kiwis was 39 cents per kiwi. Okay, well then what would 4 kiwis be? Times 4? Times 4, what would that give me? 56 cents? Okay, the pears would be, what's that? 31 cents per pair. We just need to buy 2 pairs. So that's going to be 62 cents. Now what do you need to do with those 2 amounts? Add them together. What's that going to be? $2.18. That's 8. That's all 8. Okay, that page is out of 1, 2, 3, 4, 5, 6, 7, 8, 12, 13, right? Does that seem right, guys? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay? Next page.
13.
All right. Better buy questions. You knew it was going to be there. This is exactly what we knew that it was going to be there. Again, there will be one just like it on the test. It just might not be Captain Crunch. It might be Life Cereal or something else. I don't know. Okay, so you're going to have to do it. I'm going to do my proportions up here where there's a little more space. So it specifically says per ounce. Now, isn't that the unit price, guys?
Yeah.
Yeah, absolutely it is. That's the cost per, in this case, ounce. Okay? So we're going to have 2 proportions. You must have this. If you didn't have this, it's wrong. This one will be Target over here. This one will be Kroger over here. So I know that at Target, remember money's got to be on top, right? Because we're doing per ounce. So ounces, ounces, money, money. Okay, we have $5.60 for 16 ounces. And for this one, I have, okay, so then the Kroger is selling a little bit bigger of a box, but obviously you're going to pay a little bit more. So we need to figure out which one of these is actually the better deal. So you could cross multiply and divide, or just know that you're dividing by 16 to both top and bottom. You end up getting what here? 35 cents?
Yeah.
31 cents.
35.
35 cents. And then over here, you're dividing 20, you're going to get 31 cents. Okay? Right? So obviously, which one is the better buy? Obviously, it's Kroger, because you're paying less money per ounce. Obviously, right?
Can you do that
You-
one in your video?
Yes, probably. Okay? Now, number 24, how much will you save per ounce? Well, you're saving, so you just got to subtract it. And you're going to get, that's how much money you would save by doing that one, by getting it from Kroger. Per ounce. Per ounce. Doesn't mean that's how much you're going to save. You're going to pay more money up front because it's a bigger box, but you're going to get more. Okay, next one. We're just going to skip this one, I think. Not even going to worry about it. There's 2 possible answers on it, and I'm not gonna worry about it. You can ask me later if you got it right.
2 answers.
I gotta look because I haven't. It would be. I would accept 40 or 8. I think it was 8. No, it's 40. No, it's 40. All right. Okay. Here we go. These are all learning target number 9. Obviously, you need 5 proportions. Okay, so we'll do the first one. You just look at your labels first, so we know we're doing quarts to cups. Quarts to cups. The fake ratio is always the conversion ratio. There's this many of this and 1 of this. Okay, so when I look down here, I know, oh, there in 1 quart there are 4 cups. Now I'm just going to put on whatever it gave me. 3 quarts. Times 3 times 3 would be 12 cups.
Will you put quarts on the bottom?
It doesn't matter. Remember, when you're doing conversions, you can always have these flip-flopped. It doesn't matter. Okay, just as long as you keep it all consistent. But if you didn't have labels, count it wrong. Again, I will count it wrong on the test if you don't have labels. Okay, next one, we're doing inches to feet. It doesn't matter. I'll do feet to inches, I guess. It doesn't really matter. You can do inches to feet also. Your conversion ratio, your fake ratio is that I know that there are 12 inches in 1 foot, right? So then how many inches in 15 feet? Well, cross multiply divide, or just know that you'd be multiplying by 15 to top and bottom. That is going to be 180. Next one, we got 2 tons. So we're doing tons to pounds. Tons to pounds. I know that 1 ton equals 2,000 pounds. It's down there below. So what about 2 tons? That one was straight from the worksheet on that. You're going to have 4,000 pounds. Okay. Next one, we're doing ounces to pounds and ounces to pounds. I know that there are 16 ounces in a pound. And what if I had 48 ounces? This one you might not know off the top of your head that it's multiplying by 3. So you may have to cross multiply divide. Regardless, you will find the answer to be 3 pounds. Okay, and the last one, you're doing meters to centimeters. Meters to centimeters. And that is going to be, there are, 100 centimeters in 1 meter. And we have 28 meters, so times 28 would be 2,800. 2,800. This page is going to be out of 1, 2, we're skipping that one, 7, right? 7. We're skipping this one, remember? This page is out of 7. What's up?
I said it was 8.
Yeah, well, we skipped that one. All right. Okay, these ones, the modeling, I told you guys, we did that modeling for a couple days. And you guys, I think, thought after we did it the second day, you thought it was pretty easy, I believe. But these were about as basic of the models as you could even get, right? They're pretty basic. Okay. Now, what's the whole goal of a model again? Who can remind me? What's the whole point to modeling ever when we do a bar model? What are we trying to accomplish? Who remembers? Nobody knows? Okay. Remember, isn't it to try to figure out what one of these little rectangles equals? Isn't that the whole point? So obviously you're given a fake ratio. Sure, you could do edge pieces if you wanted to. You could say Joseph Sarah prepares cranberry apple juice. 5 parts cranberry to 3 parts apple, so that means 5 cran, 3 apple, which would mean 8 total. 8 total, right? So, as you can see, the fake ratio has been modeled out here. Now you just got to see the real information. That's what you've got to identify. So here's my real. Okay, I got to determine whether that 200 milliliters, I got to determine if that means both all 7, or all 8, just the apple, just the cranberry. I gave it to you, so you knew. Oh, well, it's right there. So that means that it's going to be a total. So in order to figure out how much of one of these parts is, I'm going to do 200, and I'm going to divide it by 8, right? Which is going to give me what?
25.
Oh yeah, down 25. So now, and some of you write it in here like this. Some of you do that. I'm fine either way. I've seen other ways where people have gone and done these kind of things, where they do that and say, well, that means one of those is 25. But when you do that, it's pretty easy, right? Because you know that if you're trying to figure out how much apple juice you have, well, 25 plus 25 plus 25 is going to give me 75 milliliters. Okay? And then what is the volume of cranberry juice? Well, 25 times 5 is going to be 125. Shouldn't those two things add up to be 200, guys? They better, or you did something wrong. Now, you didn't have to check with the proportion, but I had a lot of you asking me, should we? Well, sure you should. Why not? Why wouldn't you just take an extra 2 minutes to just write up a proportion real quick? So, here we go. I look at my question. What is the volume of apple juice used? And what was given up here? Well, they gave me a total, and they're asking for apple. So apple to total, apple to total. My fake ratio would be 3 to 8, right? And then I put 200 there, Cross multiply and divide. I'm going to get 75. Checked. We're all good. I did it in 2 ways to ensure that I didn't get it wrong. I suggest you guys do this. You should be writing this on your paper now just so that you have it, because I want you guys to do it on the summative. Okay? Down here, it's giving me cranberry juice, and obviously it gave me a real total. Total. So this is going to be 5 to 200. I'm sorry. 5 to 8. And then 200 would go here. Cross multiply divide. You would get 125. Check. So we just confirmed what we already knew. Everybody good with that? Okay. This one here, pretty easy, obviously, because this is about as easy as it could be. You have 140 shots. That's representing that bar, and you have 7 bars, or 7 sections inside that bar. So obviously you're going to do 140 divided by 7. That's going to put 20 in each one, which means he made 20 in 1 minute, right? Now, should you have checked with the proportion?
Yeah.
Yeah, guys, anytime you're given that kind of real information like that, you know that one's going to go there, minutes here, shots here, shots. I know the fake ratio is 140 and 7. Divide 7, divide 7. That's going to be 20 shots in a minute. You guys all understand that? Okay. All right. Now, this question about Mrs. Teliak. Now, this question right here is exactly what we talked about on number 2. If we can think back to that one. You guys remember that? When we were adding students to the academic lab. You just can't look at it and see the word, that she's adding cats and just think, oh, well, then it must be no. Because I proved to you already that you can add in some situations as long as they're equivalent at the end. So, let's start with the fake information. She has at home 3 grays to 9 orange cats. If you wanted to, you could do edge pieces. You could say, okay, that's 3 grays to 9 oranges, which means she has 12 total at home. Right? That's just getting the information out there that you know. That would just kind of get you thinking in the right direction. Okay? So, let's see what she did when she went to the animal shelter. She fell in love with 2 more grays and 6 oranges. If she rescues those cats, will her ratio remain the same? So, we're looking, this was the original, right? Right, guys? That's what she started with. That's what she had before she went to the shelter. Now she's going to add 2 more grays, which is going to give her 5 grays. And then she's going to add 6 orange, which is going to be 15 oranges. Right? So, how many different ways do you know how to check for equivalency? I hope you're all writing this, by the way. I hope you would be writing this, because this question is going to be on the summative. So I wouldn't see why you wouldn't be doing this right now. How many different ways do you know how to check for equivalency? Lucas? You could cross multiply. So we can do cross products. We can say, okay, I'm going to multiply them diagonally. 9 times 5 is 45. 15 times 3, is that 45? Uh-oh, right there we've proven yes. So right now we think our answer is yes. Okay? Can we divide, guys? 3 divided by 9?
Yeah.
And by the way, isn't that just finding a unit rate? Isn't that what that is? You can always use unit rates. That's what division is. Okay? We would get 0.3 repeating and 0.3 repeating. Right? Could I also simplify them? That would give me 1 gray for every 3 oranges. That would give me 1 gray for every 3 oranges. Those 3 methods just proved yes. So, if you showed this, I'm happy with that. I will accept it if you showed me that. If you explained it in some way where you said because she would, when she added those amount of cats, they would be an equivalent ratio, that's fine too. This one really not a learning target on this one because, again, it kind of just covers the general idea behind it. I want to also talk about what she just said. She said you could also look at whatever you're adding too. Okay? And you can look at that and say, okay, I can do cross products there too. You see what I'm saying? Regardless, you're still going to get 1 to 3 ratio. you're still going to get the decimal 0.3 repeating. You're still going to get the same. So it doesn't have to be after. You can do it however you'd like. You can add it and find the after and the before and compare them, or you can compare the whatever you added ratio. So I added 2 grays and 6 oranges. Does everybody understand that? So that goes against what that's the opposite of number 1. Remember on number 1, they just added 5. Remember they added 6 girls and 3 boys, or 5 boys and 5 girls. Even though they did that, they still weren't the same. Okay? So you just got to make sure you're checking it. Okay, that page is out of 4. All right. Here we go. You just had to fill in this table. Not very difficult. Like here, I'm looking at my cups of ginger ale. What am I doing to my cups of ginger ale there?
Times 2.
I'm timesing it by 2, so what do I got to do to my cups of fruit juice?
2.
So that's going to be 8. What did I do then to go from 8 cups of fruit juice to times 2? So then this will be 20, right?
Yeah.
So I know my points are going to be 4, 5, 8, 10, and 16, 20. If you had that, give yourself a check. That's 1 point right there. That's 1 point. So if you got the table right, which was pretty basic, I think. Okay. Next, we've got to plot this. Okay. We've got to plot this. Now you should always label your graph. So you need to do that now. If you didn't label it, it's wrong. Okay. So these are our x's. So we know that the x-axis is this one. Okay. So then this is going to be fruit juice. Over here is going to be ginger ale. Okay. Now we just got to plot them. Pretty easy. We got the 0.45, so we go over 4 up to 5. Right there's the first coordinate we have. Then we go from 8 to 10, so we go over to 8 up to, where's 10? Help me. Is that right?
Yeah.
8. And then we went to 16, 20, so we go over to 16.
To the top.
It is very top. Does that look right?
Yeah.
That's 20.
That's 20.
That's 16. Okay. Now, if you didn't do this, it's wrong. You always got to connect your dots together. Okay? So if you didn't do that, write yourself a note. Connect points always. Always connect points. It's the whole point of a line graph. Okay? Even though that's not a line graph, it's the whole point of what I want to say. When you're plotting coordinates and you're trying to construct a line, that's the whole point. So if you have that right there, give yourself another check on learning target number 2. Now, we have to go to describe the pattern in the graph. Okay, so we are describing the pattern in the graph. Okay, I will accept a couple different things. First of all, what I'm really looking for here is I'm just looking for you to use the word constant. It's a constant rate of change. That's what I'm really looking for there. Because these are all equivalent, guys, I can tell you right now this is going to be on the summative. That question right there, describe the pattern. Hold on, guys. I'll just give me a sec. That's going to be on there. If you guys write constant rate of change on it, it will be right. Because it has to be constant because these are all equivalent. Every ratio in there is equivalent, right? Because we use the same rule. I knew, oh, okay, I'm timesing by 2, so I've got to times by 2. I'm doubling here, so I'm doubling here. It has to always be a constant. So I suggest everybody write that, circle it, and know it, because that's what I want. That's all I'm going to accept, actually. Because that's what the way we set it in Learning Target 2. Okay? So if you had anything other than that, it's wrong. Okay?
Constant what?
Constant rate of change, which means it's changing at the same rate, which is why I was able to connect them with a straight line. I wouldn't have a point right there, right? Because think about it. If they're all equivalent, they should all fall in this line. If I go right here, guys, look at this. If my graph's really accurate, right there, if I go to that point is, what is that number?
19. 13.
13. And then what's that? 13, 16. See, my line's a little bit too thick. You can get into decimals, but I know every point on this line would be an equivalent ratio to 16 to 20, 8 to 10. But you got to understand that looks like it's right on the intersection, but it might not be. It could be, like 12.859. You see what I'm saying? So everything on that line is equivalent. So it doesn't matter. If I want to figure out how many cups of juice if I want to go extend this out and go over to 30, and I went straight up to where that line, I could figure out how many cups of ginger ale that would be for 30 cups of fruit juice. Okay, so that one's worth another point there. So that was 3 points total for that whole question. Hold on, guys. You're gonna have to hold your question till the end so we can finish. Okay, this one, what I was really looking for, you could do it 2 ways. You could have used scaling. Okay, we want to know 15 pens, so we could scale here, and we could say, okay, what could I scale to go from 6 to 15? 3. And then what would this be? 2. What am I doing to go from 3 to 15? By 5. So then this would be $10. Some of you I saw were using a proportion. You should always check with a proportion. We want to know how much money he would spend on 15 pens. So my fake ratio is that he spends $4 on 6 pens. Here's 15. Can you just cross multiply and divide? You got it. Same thing. 10 pens. Okay. Now, how many pens can he buy for 20? 2 ways you could have done it. You know, this is 10 now. You could have extended this out. How many of you extended your chart out a little bit? It's fine. You would learn that it's going to be, he could buy 30 pens. Right? If you're doing this as a proportion, you would say, okay, I know that we are doing pens to dollars. Pens to dollars could be either one. My fake ratio is that there are 6 pens for $4. Okay, I just fill in what I know. Times 5 would be 30 pens. See how I did that? Just using the fake ratio. And I could have used any one of these fake ratios. Any one of them for my proportion.
How many is it out of?
Okay, this back page is out of 5. So that makes the entire thing out of 5. 9, 16, 29, 38. The entire thing is going to be out of 38 points.